Hi there. So today we're going to be looking at ellipses, and an ellipse is where you have a cone. It's going to have a plane that goes through it at an angle, and that's going to create a circle which gets stretched. And so now you have an oval shape. There are two equations for ellipses, and you'll notice it's x minus h squared plus y minus k squared. And when you want it in standard form, you always want the equation equal to 1. Now, what makes this an ellipse instead of a circle is you have these multipliers that are going to stretch it. And you can see that these two equations look very similar. So the only difference is a squared comes first here when you get a stretch along the x-axis. And a squared is here underneath the y's when you get a stretch along the y-axis. Now, by the way, how do you know which of these is the a squared? A squared is always the largest number. So let's look at this in more detail. Here are some definitions for you. Now, what's interesting is in the ellipse, there are two fixed points to create the ellipse. So plural of focus is foci. You also have two vertices, which we are going to call A's, and two, I put that in the wrong place. Fix. Two vertices, which we're going to call A's. We're going to have two co-vertices, which we're going to call B's. The center of the ellipse is going to be HK, and the center, the minor axis is where you're going to have the co-vertices. The major axis is where you're going to have the two vertices. The major axis is always going to be the longer axis, or the stretch, where you get the bigger stretch. So let's look at a picture of this. Here are two ellipses. I'm going to refer to the first ellipse as a UFO because I'm thinking of it getting stretched horizontally. I'm going to think of the second ellipse as a football because it's going to get stretched vertically along the y's. Now, these two equations are the same as the other page, just there's no HK, which means that the vertices would be at, or the center of these would be at 0, 0 if there's no HK. All right, so something to note here is the C's are going to be the focus, or the foci, both of them together. And how you're going to find the C's is you're going to do a squared subtract b squared equals c squared. So that's the formula we're going to use to find the foci. And I'll show you that in the example. What I want you to see here is this is the major axis. It's the longer axis. And this here is the minor axis, or sorry, the major axis here. So I just highlighted the major axis in both of these in yellow. Now the minor axis is going to be in green, and these are always the shorter axis. So you can see there. Now the vertices are going to be your A's. From the center out to the vertice is a distance of A. And from the center to the co-vertice is going to be the distance of B. So let me show you how this works with an example. I think that will be the easiest. Example 1, draw an ellipse given this equation. Now, how we know that this is not a circle, that it's an ellipse, is you can see that in front of the x squared is a 4, and in front of the y squared is a 25. So we're getting different stretches, which makes it an oval instead of a perfect circle. Now, this is what you want to do every time. The first thing you want to do is you want this equation to be equal to 1. So how do you make 100 equal to 1? you would divide everything by 100. So we're just dividing every single thing by 100. Now 4 over 100 is going to reduce as x squared over 25. 4 goes into 4 once, don't need the 1 there, and 4 goes into 125 times. 25 goes into 25 once, so that's y squared, and 25 goes into 104 times equals 1. Now we know that this is going to be what I called a UFO because the bigger number is under the x squared. And so the stretch is going to be along the horizontal, creating what I call a UFO. And again, that's just a fun way to remember that it's an ellipse that gets stretched horizontally. So I'm going to refer to it as the UFO because that number there is larger than the 4. So my equation is x squared over a squared plus y squared over b squared is equal to 1. So looking at the standard equation, if 25 is going to be your a squared and the 4 is going to be your b squared. So now what you're going to want to do is you're going to want to write this down. A squared is equal to 25 and b squared is equal to 4. So let's figure out what a and b are. So you would square root both of these, and that gives me a is equal to 5. And when you square root these, you're going to get b is equal to 2. So now I'm ready to graph my ellipse. So the center of the ellipse, notice there's no HK. So the center is at 0, 0. From the center, we are going to count A units, which is 5. But because it's a UFO, the A's are going to go left from the middle and right from the middle. So from the center, count to the right, 1, 2, 3, 4, 5. And to the left, 1, 2, 3, 4. 1, 2, 3, 4, 5. Okay, so I'll call this A and the opposite of A. And the major axis is going to go from opposite of A to A. That's going to be the longest axis of your ellipse. So now what we're going to do is graph the B's. And the B's are going to go up 2 and down 2. And that's the opposite of B. And then what you can do is you can just draw your UFO. And you've got your oval or your stretch horizontally into what we're referring to as a UFO. All right, so now the next thing we want to do is find the foci. So the foci are always going to be inside the ellipse, and they're always going to be on the major axis. So here is the major axis, and the foci is going to be on that blue axis. So how do we find it? We're going to do a squared subtract b squared equals c squared, and we're going to figure out what c is. So the a squared is 25, I wrote it down, and the b squared is 4, and that gives me 21. So let's do this. We're going to write this as an equation. C squared. So 21 equals c squared, and the square root of 21 is what c is. Now the square root of 21 is a little bit less than 5. So on this major axis, you would go right a little bit less than 5 and left a little bit less than 5, which is the square root of 21. And that's where your foci is. And we're going to talk about amazing things with kidney machines and buildings that are elliptical, like the Capitol, and talk about the foci. So we'll do that in class. So let's go to the next example. And we're going to write the equation of an ellipse. It has a center at 0, 0, a vertex at 0, -3, and a co-vertex at -1, 0. So what we could do is we could just draw a quick sketch of this to get a feel. The center's at 0, 0. The vertex is always going to be your A's. So 0 down, 1, 2, 3. And by the way, your A's are always on your major axis. So this is going to be a football because your A's are going up and down. Now the co-vertices are left 1, so there's a B, and right 1. And so you can see that this is going to be an ellipse in the shape of a football. So what does the equation of a football look like? Well, the equation of a football is going to be x squared over b squared plus y squared over a squared is equal to 1. So if we can just take this equation and fill in what b is and what a is, then I can write the equation. So what is a? Well, a is the distance from the center up to a. So here's a. This is a plus a. So 1, 2, 3. So a is equal to 3. And b is going to be the distance from the center out to the co-vertice, which is 1. So ready to write the equation. Here we go. X squared over b is 1. So we'll put that in as 1 squared plus y squared over a. A is 3. Distance from the middle to a vertice is 3. So that will be 3 squared is equal to 1. Square those and you're done. X squared over 1 plus y squared over 9 is equal to 1. And technically you don't really need that 1 there, so I'll just erase it and highlight. There's my equation for this ellipse that has this vertice and this co-vertice. So let's look at example 3, graph the ellipse and state its eccentricity. And I'll be explaining what eccentricity is in a moment. So the first thing we're going to do is, we know this is an ellipse because the 9 and the 25 are different stretches, and the x is squared and the y is squared. So we know that both of those are squared. Now we know it's a football, and the reason why it's a football is because the 25 is the bigger number, which means the stretch is along the y axis, which creates a football. If a squared is 25, then a is 5. If b squared is 9, then b, when you square root 9, is going to be 3. So how you're going to do this is you're going to graph the center, which is right 2 and down 1. The A's take us from the center up and the center down because it's a football. So from the center, count up 1, 2, 3, 4, 5, and count down 1, 2, 3, 4, 5. So there are your A's, and that is your major axis. Your co-vertices are your B's. From the center, you count 3, 1, 2, 3. So there's B, and 1, 2, 3, and there's the opposite of B. And then you can just draw. I'm getting really tired, so this is not going to be the best shape. But then you will draw your ellipse. Yours will look better than mine. That looks horrible. All right, so major axis is vertical because the stretch is under the y. And this is the major axis. All right, vertices. So if you wanted to write down what the vertices are, then you would take 2, and then you take -1 plus a. So -1 plus 5 is 4. So that point right there is right 2 and up 4. And then this point down here, you would take 2, and then you would take -1, subtract a. So -1 subtract 5 is -4. So this point is right 2 and down 4. Um, all right. So did I do that right? -1 subtract 5. I did not do that right. That's -6. Fix. All right. So that's right 2 and down 6. This is going to be a little shaky because it's very late. All right. The co-vertice, let me just write this in, is going to be 2 plus b, which is -1, -1, and 2 minus b, which is 5, -1. And those are your b's. The length of the major axis, well, think about it. If the distance from the center to up here is a unit, so that's the distance, then the entire axis is going to be double that. So your formula for your length of your major axis is 2 times a, so it's going to be 10. The length of your minor axis is going to be the same thing. From the center to here is b units, and from the center to here is b units. And so how do you find the length of that axis? I'll put it in purple. Here's the length of this axis. It's going to be 2b. So if 2b, it kind of got moved over here. Here's 2b. So 2 times b is equal to 6. So the minor axis is equal to 6. The foci you use for the foci, it's going to be inside on the major axis. You're going to use c squared equals a squared subtract b squared. So a squared is 25 and b squared is 9, and that equals c squared. So c squared is equal to 16. So c is equal to 4. So from the center, you're going to count up 1, 2, 3, 4. There's your c. And down 1, 1, 2, 3, 4. So that's where your foci is going to be. Now let's look at eccentricity. Eccentricity is how round your ellipse is. So as the ratio of C over A approaches 0, then the shape is going to approach a circle. So we're going to find the eccentricity of this oval by taking C divided by A. C in this case was 4 and A is 5. So the eccentricity is 4/5. And that eccentricity should be between 0 and 1. Okay, so this will be our last problem, and then we will complete the rest of these notes in class. So if you're not in class, then go ahead and keep going and complete what we have left. So you have 9x squared, and you're going to gather up your x's, plus 36x, and then you're going to end up doing plus something, okay? And then you have your y's, plus 5y squared, subtract 10y, and you're going to end up doing plus something, equals, and then take that 36 and move it over to the other side. So you'll do subtract 36 plus something plus something. Now, we haven't done this yet, but when you complete the square, A has to be 1. It can't be 9. So before I'm even ready to complete the square, I'm going to factor a 9 out here. And this would be x squared plus 4x plus something. But because this plus something that I added is being multiplied by 9, over here, this plus something also has to be multiplied by 9. And then I have plus, I'm going to take out the 5, which gives me y squared subtract 2y plus something equals, Now, the plus something, again, if I factor out the 5, then I'm going to have to multiply this plus something over on this side also by 5. All right, so now I'm ready to complete the square, which is take b, divide it by 2, and square it. So 4 divided by 2 is 2, and I'll square it. And negative 2 divided by 2 is negative 1, and I'll square it. And what that's going to equal is negative 36 plus 9 times 2 squared is 4. So 9 times 4 plus 5 times, and negative 1 squared is 1. All right, so this here is a perfect squared trinomial, which you're going to factor. And it's going to factor as x plus 2 quantity squared with the 9 in front. And again, the pattern is this plus 2 is going to be this plus 2. All right, plus 5. So plus 5 times y, and this negative 1 is here, quantity squared. So again, the pattern is if that's a minus 1, this will be a minus 1. That is going to be equal to negative 36 plus 36 plus 5 times 1 is 5. So 9 times x plus 2 squared plus 5 times the quantity of y subtract 1 squared is equal to 5. Now we're supposed to write this equation in standard form, which means this 5 is supposed to equal a 1. And so the standard form is going to be divide every single thing by 5. All right, so here we have this fraction, but if I want that fraction in the denominator, multiplying it by 9/5 is the same thing as dividing it by 5/9. So it would look like that. Plus 5 over 5 is 1, so that would be y subtract 1 quantity squared, which equals 1. And that is what this equation looks like in standard form. So the rest of the notes we will be doing in class together. If you're not in class, then go ahead and just finish up the notes. And we will be doing hyperbolas next week. Thanks, everyone.